Hello again. So now that we've done all of the other types of organic compounds, the last thing we have to do in this unit is talk about the various organic reactions. So let's go through those different types of organic reactions. The first three are probably the most important ones that you need to know. And then the other ones are, it's helpful to be familiar with them and know the basics about them. So the first one is substitution, so often called halogenation, because what you're doing is it's the replacement of a hydrogen in a saturated hydrocarbon with a halogen, which are our group 17 elements, right? So we call that halogenation. So we're replacing a hydrogen with a halogen in a saturated hydrocarbon. So it's got to be saturated. So let's look at an example. Let's say we have this plus Cl2. What do we get? All right, so what happens here is this chlorine will come over and break a bond, knock out an H, and replace it. So what are we left with? Now we're left with, here's our 2 carbons and our hydrogens, right? But now we knocked out that hydrogen and replaced it with a chlorine. So that's halogenation. We're adding in and we're replacing a hydrogen with a halogen. So now where did the other chlorine go? It's Cl2. Well, that's easy. The hydrogen that got knocked off joins up with that chlorine, and we get, in this case, HCl. So that's it. Pretty simple. So this is substitution. We're substituting. We're knocking out a hydrogen and replacing it. So the other thing you want to look for is if I give you the molecular formulas here. So this is C2H6. Now over here, it's C2H5, right? Because we lost one of the hydrogens to replace it with a chlorine. Cl. So that's what you want to look for. We lost an H in the process. So that's how you know it's substitution. You're replacing. We're knocking out an H and replacing it. So remember, substitution always starts with an alkane, a saturated hydrocarbon, and it always ends with 2 products. So because you want to be able to differentiate between this and addition, which is the next one that we're going to go into. So addition is now we're adding hydrogens, and we would call that process hydrogenation. We're adding in hydrogens or halogens. So this is another type of halogenation that we just mentioned at a double or triple bond. So we're dealing with unsaturated hydrocarbons. Right, we're dealing with an unsaturated hydrocarbon now. And we'll see how this differentiates from substitution. So let's look at an example here. So let's say I have 3 carbon. Oh, I want to make this a double bond because it's an unsaturated. So put our H's all around. Right. So now we're going to add in, let's say, bromine. Right. So what's going to happen here? So the bromines are going to come over here and they're going to break that multiple bond. So they're going to break open that bond, that shared pair of electrons right here, and that's going to open up sites on those two carbons. So now what do we have? Well, let's draw our original structure. All right, here's all of our hydrogens that we had, that we started out with. But now, because we broke that double bond, each carbon needs to form 4 bonds. So now we have an open bond site here and an open bond site here. Who's going to join up there? The 2 bromines. So 1 Br here and 1 Br here. So that's addition. We're adding on. So addition always starts with an alkene or an alkyne, and it always ends with only one product, right? Because both of those halogens joined on, so we don't have an extra one to join up with any H that got knocked off, because no H's got knocked off, right? So remember substitution and how these two differ from each other. So also use the molecular formula to kind of help you out too, because sometimes you'll just see that. So this is C3H6 initially, right? It's an alkene, CnH2n. And now over here, it's C3. It still has 6 H's, and now it has 2 Brs. So notice what happened here. We didn't lose any H's because it's addition. We're adding on, right? We're opening up these bond sites and adding on those atoms without losing any H's in the process. So that's why we call it addition rather than substitution. So know how to differentiate between the two. Now, the other process here, hydrogenation, let's say we had the same thing here. All right, let's say we had the same thing here. But instead of halogens, we added in hydrogens. So what do you get? Now we get so here's what we started with, but now we broke that double bond, freed up these sites, and now we're adding in hydrogens. So we call this process hydrogenation. So we're adding in hydrogens and we're saturating an unsaturated hydrocarbon, right? That's how we saturate hydrocarbons. So we're breaking those double bonds or triple bond if that were here, and we're adding in hydrogens. So that we call hydrogenation. So next up is esterification. So this is the making of an ester. All right, so easy to remember there. So it helps to remember the general equations here. So here you're always going to have the same general equation. You're going to have an organic acid plus an alcohol is going to make an ester, and good old H2O, water. So it's always the same thing. All that's going to change is the organic acid and the alcohol that you're using, and that's going to make a different ester. So these processes are important because remember we talked about esters earlier on, and those are used a lot in flavoring and fragrances. So these are manufactured in factories. So esterification process is done all the time when you're making perfumes, scented candles, soaps, all that kind of stuff, where we're making these esters. So if we were in class, we would make an ester. It's a pretty cool lab, but Can't do that. So here we are. So let's look at an example. So let's say I have I'm going to make this one a different color so you can see what's going on here. So here's my alcohol. I'll say my alcohol is and I'm just going to put my OH backwards so we can kind of see what's going on here. I'll show you the reason for that in a second. And that's going to make what? All right. So what do we get out of this? Well, what's going to happen here is this is my organic acid over here, right? COOH, my organic acid. So remember, acids produce H plus ions in solution. So this H right here is going to come off. And then this OH in the alcohol is going to come off. And H and OH make H2O. All right, so now those two are going to come off and form water, which is going to be one of our products. And now what else do we get? Well, now we have, here's my organic acid, my double O. But now my H is gone. So this oxygen wants to form another bond. Oxygen needs two bonds. So who's it going to form a bond with? Well, if the OH came off, now this carbon wants to form another bond. So the rest of this molecule here is just going to link up and join on over here. So here's my alcohol, 1, 2, so now we're going to join up right here. And we get our new compound, which is an ester. Here's my COO, right? There's my functional group of my ester. Plus, we're going to also get H2O because of the water that we removed in order to get these two molecules to join together. So this process we call esterification. Organic acid plus an alcohol makes an ester and water. So where did that water come from? The H and the OH came together, and that removed those, that freed up those sites on these two molecules so that we can just push them together. That's it. So you're just kind of linking those together like cars on a train. And that's esterification. So what would these be called? Let's practice again, right? So 2-carbon organic acid would be ethanoic acid. And then a 2-carbon alcohol would be ethanol. And what do we get? Well, here's my ester. Remember, the L of the functional group points towards the alkyl group. So the alcohol becomes the alkyl group. So maybe that helps you too. And we get ethyl, our 2 carbons. And then we've got 2 carbons left on the other side. That's prefix eth. And then those end in ethanoate. So we got ethyl ethanoate is the ester that we produced here. So that's esterification. So this and the last two reactions are probably the most important of the organic reactions that you want to know. So let's just go through the rest of them and be familiar with them. So the next is saponification. And this is the making of, not sap, soap. So I don't know why they don't call it saponification, but that's just the way it is. So what is this? It's always going to be a fat plus a base makes glycerol, type of alcohol, and soap. So that's saponification here, right? So here's your fat. So you don't really have to be able to name these or anything, but remember back to living environment, what is a fat? It's a glycerol and 3 fatty acids. So here's your big fat molecule. It's a big molecule, big fat molecule, plus your base, so hydroxide, sodium hydroxide, and you're going to get glycerol and soap. So you don't really need to know much more about this type of reaction. Next up is fermentation. So this is the making of alcohol. So fermentation makes alcohol. So you're using sugars to make alcohol. So what's our general equation here? Well, you're going to start with some kind of sugar, and it's going to be broken down with an enzyme, and we're going to get alcohol and CO2. So this is how, consumable alcohols are made, some sort of sugar. So if you're making wine, the sugar's in the grapes, right? If you're making beer, the sugar is in the barley. So, and then these various other hard liquors and stuff where you're making your alcohols from different grains or whatever. So that's the process. So here's an example. So let's say I have good old C6H12O6, and I break that down with an enzyme, and your enzyme is often yeast, right? So yeast is the enzyme used. If you're making your alcohols or your wines, whatever, you put yeast in there, and that's what's going to do this fermentation process and make the alcohol from the sugars in those substances, whatever they are. So what do we get? We're going to get an alcohol. So in this case, we're going to get C2H5OH, our alcohol, plus we're going to get CO2. So again, just be able to identify these. A sugar broken down to make alcohol and carbon dioxide, and that's it. Next up is combustion, and we've talked about combustion before. You're taking saturated hydrocarbons, and they're reacting with oxygen, and we're making carbon dioxide and water. So our general formula is we're going to have some sort of hydrocarbon, C's and H's, plus oxygen makes CO2 and H2O. We did this back in the beginning of the year, the first lab we ever did, that candle lab, where we did the process of combustion, right? If you take oxygen out of the equation, the flame goes out. So you need oxygen for combustion. So let's look at an example. Let's say we have C3H8, that's a gas, plus oxygen, and that makes CO2 and water. Right, so all that's going to change is who the fuel is, right? Who the hydrocarbon is. That's our fuel that we're combusting using oxygen. So in this case, C3H8, it's alkane, 3 carbons. This is propane. So this is the process that goes on in your barbecue when you're making some burgers and dogs, having a barbecue. This is what's in that tank that you hook up to your barbecue, and you're burning that to produce energy to cook your food. So this is combustion. Same thing over and over. All that changes is the fuel, and we've seen these reactions before. The last one we call polymerization. So we call this polymerization because remember, poly means many. So it's the formation of a large molecule, which we call a polymer, from smaller molecules, which we call monomers. Mono means one, right? So we're making a big, many unit molecule from smaller units. All right, so here's the example. So we have these smaller monomers that ... just means you have a bunch of them. So it's never going to just be there's two of them. There's hundreds and thousands of these that we're linking together into a big long chain. And that's what the ... dots here. It's just going off in either direction, big long chains of carbons that we're producing. Right. So there's two types of polymerization. One is addition polymerization, where we're joining monomers of unsaturated compounds. So we've got a double or a triple bond in there somewhere, and we're breaking those and freeing up those sites. So sometimes the Regents likes to show it to you weird like this, where they'll say NC2H4s are my example here, are joining together to make and now the N's a subscript. So the N went from a big number in front to a little subscript. So that means we've taken N monomers and made a polymer N units long. Okay. So remember what N means. N is just a number. So some number of molecules. And it's not just going to be like 2, 3, 4. It'll be like hundreds of these, thousands of these that we're joining together. So think back to my analogy, like I said before, of joining together the cars on a train. So each monomer is a car on the train, and we're freeing up those bond sites and joining those monomers together to make a big long chain. So that's addition polymerization. We're just adding them together because we can open up these bond sites by breaking those double or triple bonds without losing any atoms in the process. So just like the process of addition that we talked about earlier, we're just adding on and we're not replacing anything. But condensation polymerization, it's a little bit different. You're joining monomers by the removal of water, right? Think about condensation like on a glass, on a cold glass of water on a hot summer day. You're getting that condensation building up on the outside. So we call this process dehydration, right? So dehydration synthesis, you remember that from living environment. So you're removing water to free up bond sites and join those monomers together. So one thing you want to remember is that water is always a product in condensation polymerization. So here it is down here, right? We're making water. So same thing as before with esterification, the H and the OH are coming off to make H2O, and then that opens up those sites, and then those two monomers just link together. And that's the same thing that's going on across the board here. So that's dehydration synthesis. We're removing water for the purpose of freeing up bond sites and linking those units together into one larger, big, long chain, which we call a polymer. So this is a process called polymerization, and this one specifically, look what we're making. We're making something called polyester. So what is a polyester? It's a long chain of esters. So this is a substance used in making clothing these days. You know, those moisture wicking clothes and all that stuff has polyester in it. So this is how they make polyester. It's a polymerization process. So that pretty much wraps up this unit in terms of new material, and that also wraps up the year. So that was the last bit of information in the Regents Chemistry curriculum. So we are all done. Yay! So normally we would review for the Regents and take a Regents, but that's not going to happen. So all we're going to do is take an organic unit test. And that'll roll us right into summer. Womp womp. Alrighty. Adios.